In this clip, I'm going to discuss a topic I touched on in my last video. What should you design up front? To start, let's look again at the Agile Manifesto. One of the values is working software over comprehensive documentation. And another one is responding to change over following a plan. So, Agile emphasizes not to invest too much time in designing everything up front. Does that mean design patterns aren't relevant? In Design Patterns Explained, Shallow and Trott argue that by learning design patterns, you will learn the qualities of good code and good design. And if you look at the principles behind Agile processes and design patterns, they both value no redundancy, readability, and testability of software. What do we mean by no redundancy? This is also called the dry principle. Don't repeat yourself. If you copy-paste a lot of stuff, you end up with code that's hard to maintain. If you fix a bug in your code, you don't want to spend your time going over all the places where you copied that code to fix it there as well. And you surely forget one or two of them, and the bug that you thought was fixed still exists somewhere in your code base. Instead of copy-pasting, encapsulate the changes behind an interface. If you apply design patterns, this kind of behavior becomes a habit, and you can reuse your code more easily. Another aspect is readability. Phil Carlton said, "There are only two hard things in computer science: cache invalidation and naming things." Think about what's the best name for objects and methods, so they explain what they do themselves. If you need to add a lot of comments somewhere, this is probably a sign there is an issue with naming. Keep methods short and give them one responsibility only. So if you keep your methods short and simple and as independent as possible, this makes them a lot easier to test. If methods are tightly coupled, exchanging lots of information between them, or weakly cohesive, doing too many different things, testing them is hard, and you will more quickly break things. What happens if I change this floating point variable here to... The idea of Agile is that you release a new version of the product in every iteration. Some features can be implemented in a single iteration though. This means you'll have to lay the groundwork for the feature by implementing it partially, and then extend it a following sprint. How do you design this? It means you need to always design with extensibility in mind. And this is exactly where design patterns excel. In summary, although design patterns and agile practices seem at odds with each other, they actually share the same ideas about what makes great code. Let's look at an example. A video rental store. So what do we have here? There's a movie class that defines 3 different price codes, one for children's movies, a standard price, and a price for newly released movies. The rental class keeps track of how many days a movie has been rented. And finally, the customer class records a list of rentals. Something you see commonly in badly designed code is the so-called wicked switch. This particular example is written in C#. Python doesn't have a switch statement, but you can write the same badly designed code with an if-else statement. Switches or if-else statements are not intrinsically bad, but you have to be careful using them. If you use them, it generally means that you didn't encapsulate a variation properly. Dealing with variation means you'll have to change code in multiple places if something changes. For example, the video service will not only rent movies but also provide streaming services and use a new quality level, 4K. And as we know by now, requirements always change. But if requirements always change, what good are design patterns then? Or any design, for that matter. Isn't it better to just hack something together quickly and call it a day? Here's an analogy. Every time you print a document, it's easier to put it on your desk than to file it away. If you only have a few documents to manage, this is no problem. If you need to handle lots of documents, you'll need some kind of system. Otherwise, you end up in a big pile of paper. In other words, cutting corners in the short term may result in having to pay the price in the long term. So it seems there are only two choices. Either you lose a lot of time and over-design everything, or you do everything quick and dirty, but you pay the price later. There's a third way. Don't design everything up front, but do think about where changes are most likely to happen. If requirements change, and they always do, you still need to change your code. There's no way around it. But hopefully, your upfront thinking makes changing your code a lot easier. Everybody cuts corners all the time. A good designer knows which corners to cut and which not. To conclude, here are again the most important principles of good design. Program to an interface, not an implementation. Favor aggregation over inheritance. And finally, encapsulate the concept that varies. Please post any questions you have about this in the Teams channel. Thanks for watching, and catch you in the next one.